Well, finally we're in the thermosphere, and this is where things really start heating up. Sorry, it's an astrophysics joke. Well, let's deal with the quacks debunking. The thermosphere gets touted as a rock-solid gotcha by the conspiracy nuts, especially the space is fake people. And the trouble is, they're wrong, because do your own research never seems to mean actually learning anything. It only ever goes as far as reading enough to support your bias and then stopping. In the second video of this series, we talked about why temperature and heat mean two different things, and this is why. The average temperature in the thermosphere is wild, and it can go from 500 degrees C all the way up to 2000 degrees centigrade. So how come rockets don't melt? Well, like I said, it's the average temperature of individual particles, and at this altitude there are just too few particles. So if a molecule of oxygen is at 2000 degrees, and it collides with a rocket, the energy is very easily absorbed and spread out among the molecules of that rocket because there's so many more of them. It's like a drop of hot water that's landed in a cold bath. It's going to have very little effect on the temperature average of that bath. So why are they so hot? Well, at this altitude, they're the first line for all of the radiation energy from the sun. So if ultraviolet or X-ray photons hit a molecule of oxygen in the thermosphere, all of the energy is passed to that one molecule. And because there's nowhere for it to dissipate, that molecule has to hold on to that energy until it hits something else and can transfer energy, or until it just travels off into space because it's got too much kinetic energy. The molecules in the thermosphere cover a huge area, and this is the boundary between the atmosphere and the exosphere. The reality is there's no hard line between the atmosphere and the vacuum of space. At this altitude, it's all about different forces acting on molecules. Gravity's pulling them towards the planet, but solar energy is colliding with the molecules and trying to give them kinetic energy. And sometimes it's enough to push them away from the planet. Whereas where the atmosphere ends and the exosphere starts is generally a very broad area where the average effect of gravity has less of an effect than the average of solar winds. But we have another force at play. The Earth has a magnetic field, and this has a big impact on the thermosphere. Where particularly high energy radiation has hit a molecule, it strips away the electrons and converts that molecule into an ion. And because that ion has a charge, these ionized gases interact with the magnetic fields, unlike the non-ionized atoms and molecules, so they form an ionization layer in the atmosphere. And the density of this is entirely dependent on solar activity, but it creates two useful things for us way down in the troposphere. Firstly, it creates patches of atmosphere that interact with radio waves, and we can use this to our advantage to bounce off radio emissions back to the Earth. Amateur radio enthusiasts monitor solar activity quite intensely to take advantage of this. See, line of sight communication is very much limited by the curve of the Earth, so radio waves don't pass through the ground quite so well, but they do tend to bounce off it. And in ideal conditions, you can bounce radio waves from the ionosphere to the ground and then back again in a process known as skipping. And they can transmit and receive signals over vast distances around the Earth by doing this skipping. Again, this wouldn't matter on a flat Earth because everything would be in line of sight, so you wouldn't need to use skip. Oh, and secondly, the magnetic field helps trap high energy ions and stops them from being blown away into the void and turning us into a thin atmosphere like Mars, which would suck. We'd still have an atmosphere, it's just it wouldn't be very thick and breathing would no longer be an option. It's also why we get auroras at the poles, but let's get into that another time. See, now we're at the exosphere, deep space basically, where particles are fewer than buses in a Welsh village on a Sunday.